Okay, so today we are going to talk about postulates, and then we're going to do a paragraph proof. And a postulate is something that we assume. We define things. We talked about definitions yesterday. And postulates are things that we assume, and we can't generally do things without some assumptions. Theorems are all must be proven using geometric proof. So most postulates are pretty much everybody just agrees that they're true. And these five postulates are Euclid's postulates that he used to write the first geometry book. We kind of might use a few other things that we don't feel like proving, but here's what they mean. A straight line can be drawn joining any 2 points. So if I put a point here and a point here, I can draw a line between them. And yeah, it might be a little easier to draw that line without, if I could put my ruler on my screen, but I can't, it's on a different pad. But there is a line connecting the 2 points. Okay, the second one says that I can extend this line, oops, indefinitely in either direction. Because you probably know that lines go forever. And so I've made you extend lines before. And you can do that. I can't really get it very well because I'm writing on a pad that I can't see my line. But you can take your line, you can put a ruler on it, you can extend it forever. The third one says, given a straight line segment, I can call this a radius for a circle. I don't have a compass for that. So there's my circle. Yay, I have a circle. So any line segment I can turn into a circle radius. And we've talked about the definition of a circle being all the points equal distance from this point. So they all have the same radius, all congruent or the same as that line segment. So this radius is the same length. There's my tick marks indicating the same length. Okay, I'm gonna clear this one off. Make room for the last one. The fourth one says all right angles are congruent. That means all right angles are equal to each other. 90 degrees is 90 degrees. Okay. The last one, this is the really famous postulate. This is known as the parallel postulate. It says if two lines are drawn which intersect this third line in such a way that the sum of the angles sums to two right angles. That means 180 degrees. If it says it sums to less than two right angles, they will intersect. We're going to do a little bit simplified version of that, which says, and we're going to call it the same side interior angles postulate. If, I suppose I should label my lines. So I've talked to you about points being capital letters. Lines are going to be lowercase letters. And my same side interior angles postulate, you're going to want to get this written down. And again, I'm going to abbreviate postulate with post. Really, I'm going to have an abbreviation here, SSIA post is what I'm going to use when I do proofs, because writing it out takes forever. So if measure of angle 1, these are called same side interior because they are on the same side of line P, which is called the transversal. They're on the same side of it. They're both on the right side, and they're interior to my parallel lines L and M. So if measure of angle 1 plus measure of angle 2 equals 180, or if same side interior angles equal 100, add to 180, then line L is parallel to line M. And I'm just going to use the symbols L. Notice when I'm doing L, these are lowercase letters. P is a little hard to tell, but it's lowercase. Lowercase L, I'm using a cursive L because a printed L looks like a 1. This is a 1 here. So angles should all be labeled with numbers or given a name based on the capital letter postulate or points. So same side interior angles postulate is a little bit of a summary of this. Of if measure of angle 1 plus measure of angle 2 equals 180, then L is parallel to M. Or if same side interior angles are add to 180, then the lines are parallel. So we're going to do a little proof of this. And this is going to be called the corresponding angles theorem. And I'm going to do it as a paragraph proof, which means I'm just writing it out. Angles theorem. It's a theorem, so that means I'm going to prove it. I don't have a very good abbreviation for this one. So here it goes. So I am given, so your problem's going to say something like given L is parallel to M, and my corresponding angles here are going to be 1, 1, and 3. And then it'll say prove, and it'll give you the diagram as well. Angle 1 is congruent to angle 3. Because corresponding angles are in the same spot on the parallel lines, just on a different line. 1 and 3 are both upper right. So, paragraph proof, I write a paragraph. I am given, and you can use math notation in there, that L is parallel to M. That's a sentence. This tells me that 1 and 2 have to add to 180 by the same side interior angles postulate. So I'm going to say this tells me that measure of angle 1 plus measure of angle 2 equals 180 degrees by the, and I'm going to use the abbreviation I said, SSIA, same side interior angles postulate. Now, if I were doing this in a formal proof that I was submitting to a book, I wouldn't use abbreviations. Okay. I also know that measure of angle 2 plus measure of angle 3 equals 180 because they make a line. We call that the linear pair theorem. So that means since both of these are equal to 180, measure of angle 1 plus measure of angle 2 is going to equal measure of angle 2 plus measure of angle 3. By the transitive property. So if I subtract measure of angle 2 from both sides, that will cancel out. I'm going to write this out. This wouldn't really be in my proof, but I want to show that it is. They're going to cancel out, and I'm going to just have measure of angle 1 equals measure of angle 3. By the subtraction property. And finally, so if the measures are equal, they must be congruent. So angle 1 is congruent to angle 3 by the definition of congruence. And this is my paragraph proof. Okay, so I've just proved the corresponding angle theorem in a paragraph proof, but it was really important that I needed that same side interior angles postulate to do that. Okay, a couple of the other postulates, they'll kind of have like this being able to draw line segments. We sometimes call that segment addition, or we did one yesterday where we put two segments together and made a whole segment that was segment addition. You'll sometimes do that with two angles that are next to each other, making a larger angle, called it angle addition. Okay. Anything that's kind of seems obvious, like really obvious, like, yeah, these are two parts of a whole, is probably a postulate. Okay, there's a little bit about postulates and theorems. So postulates are assumptions. Again, theorems are things we have proven.